Ever wonder if you could just reset your brain? Well, today we're diving deep into the neuroscience behind psilocybin. That's the psychoactive compound in magic mushrooms. We're going to unpack what's really going on inside our heads during and crucially after one of these experiences, all based on some seriously groundbreaking new research.
And this right here, this is the central mystery, isn't it? You have a drug that's only active for a handful of hours, but the effects people report, like major relief from depression, can last for months, sometimes even longer. So how in the world does such a brief chemical experience manage to trigger such profound, lasting change?
To get to the bottom of this, we're going to look at a landmark 2024 study published in the journal Nature. And this wasn't just any study. It gave scientists a totally unprecedented, high-definition look inside the human brain on psilocybin, tracking what happened not just in the moment, but for weeks after.
So how did they do it? The researchers used a technique you've probably heard of called fMRI. This awesome tool let them watch, pretty much in real time, how different regions of the brain were all talking to each other, both before the drug and during the experience.
Now, to really get what they found, we need to understand this key concept, functional connectivity. It's not about the brain's physical wiring. Instead, it's about which parts of the brain are chattering together at the same time. If two areas are constantly lighting up in sync, we can assume they're working together, that they're functionally connected.
Here's a pretty good analogy. Imagine the brain is a massive company. Functional connectivity isn't the company's org chart. It's more like looking at the email traffic. You're mapping out who's actually collaborating with whom, which departments are in constant communication to get projects done. It's the real-world workflow.
All right, so with that tool, what was the first huge discovery? Well, the study found that psilocybin just massively disrupts the brain's normal communication patterns. That typical company workflow we talked about, it gets completely shaken up.
And you can really see the contrast here. On the left, you've got the normal state. The brain's networks are organized, they're distinct. Different departments are doing their own specific jobs. But on the right, under psilocybin, that organization kind of dissolves. The networks become desynchronized, and the usual lines of communication get a lot weaker.
Now, this disruption was especially strong in one really critical network called the default mode network, or DMN. You can think of the DMN as the brain's headquarters for self-reflection. It's the part that's busy when you're thinking about yourself, your past, your future. It's basically the hub of your ego, your sense of identity.
And to really get a sense of the scale here, just look at this chart. The researchers compared the change from psilocybin to the normal ups and downs of brain activity in a day, and even to the effect of a powerful stimulant like Ritalin. As you can see, psilocybin is in a totally different league.
Let me put a number on that for you. The disruption to the brain's networks from psilocybin was more than 3 times larger than the change caused by Ritalin. So we are not talking about a subtle nudge here. This is a seismic event for the brain.
And this quote from the researchers just says it all. The change in your brain's organization is so massive, it's comparable to the difference between your brain and, well, a completely different person's brain. It's a fundamental shift in your own neural signature.
The scientific term for this state is desynchronization. And the orchestra analogy is perfect. Normally, your brain is like a well-rehearsed orchestra, with the conductor leading and every section playing its part. Psilocybin is like the conductor just walking off stage. The strict organization falls away, and the musicians start to improvise.
Okay, but that intense disruption is really only half the story. The real mystery, the big question, is what happens after the music stops? What changes, if any, actually stick around?
And this is where the study's findings get really fascinating. What they discovered was that after the drug wore off, most of the brain's connections just snapped right back to business as usual. But one very important connection didn't. It stayed weak.
This timeline lays it out perfectly. During the trip, you get that widespread desynchronization. But afterwards, for up to 3 weeks, the connection between the hippocampus and that default mode network we talked about, it remains significantly weaker. It wasn't until around the 6-month mark that it returned to its original state.
So why does this one specific connection matter so much? Well, think about what these two areas do. The hippocampus is a powerhouse for memory and emotion. The default mode network is the seat of our self. So this connection is basically the superhighway that links our emotional memories directly to our core identity.
So let's put it all together. You've got this massive brain-wide disruption followed by a very specific lingering disconnection. What does it all mean? Well, this leads us to the final piece of the puzzle, the theory of how all this could actually lead to healing.
And the key idea here is something called neuroplasticity. It's a simple but profound concept. Our brains aren't fixed. They have this incredible ability to reorganize and rewire themselves based on experience. It's how we learn anything new.
So the theory goes something like this. That intense desynchronization isn't just random noise. It's a powerful biological signal. It's like a fire alarm for the brain that says, hey, pay attention. Something really new and different is happening. And this signal seems to trigger a state of heightened plasticity. It opens up this temporary window of opportunity to reshape old, rigid, and sometimes harmful patterns of thinking.
This whole thing seems to happen as a kind of biological chain reaction. First, you get the massive desynchronization. Second, that novelty acts as a trigger, telling the brain to turn on genes related to growth. One is called BDNF, and it's basically like fertilizer for your neurons. Third, this prompts the literal physical growth of new connections in the brain. And finally, and this is the key, it's thought that these new, lasting physical connections are what create the long-term psychological changes.
The researchers themselves put it perfectly. They suggest that by temporarily weakening that rigid link between our emotional memories and our sense of self, you might actually be creating more psychological flexibility. It gives you the space to see yourself and your past in a completely new light.
So this research really reframes the whole psychedelic experience. It suggests it's not just a subjective journey through the mind, but a tangible biological process, a kind of chemical reset button that kicks off a cascade of change. And that opens up a radical and exciting new question. Could we harness this process to create powerful new tools for mental health? We're really just at the beginning of finding out.